Okay, we're going to look at kinematics. Kinematic question is actually is a differentiation and also integration of uh, dis- displacement, velocity, and acceleration. Okay. Uh, for example, before that, let's look at displacement. Displacement means it's a distance travel, is a position, is a position. That means look at this. If you have a particle at this point, then is S is positive. You have a particle at this point, then it is the displacement is negative. Why? Assuming O is the initial position, where at the start of the uh, when t is equal to 0, okay, you're at the position, we call it the 0 position here, when t equal to 0. Okay, now velocity, if its velocity is moving in this direction, it will be positive. Okay, even though an object is at the place where the distance is negative, the displacement negative. Let's say that the object is at this negative position. Okay, but if we travel in this direction, then it's still considered positive. Okay, it's an object. Let's say particles is here. Okay, at the positive s side, but if we travel this direction, then it become negative. Similarly, here is also negative. Okay, and then similarly for acceleration, you also have positive and negative acceleration. Okay, now uh, if you differentiate ds dt, okay, that means you have a function. S is a function of t. What does it mean? Means, let's say for example, s is equal to 3t squared minus t, for example. You mean ds dt 6t minus 1. Okay. The ds dt means is the chain of distance with respect with time. Okay, this is basically the chain of distance and the time taken. This is actually equal to velocity. Okay, so when you differentiate the displacement, what you get is a velocity function of a function with t. Okay, now if I differentiate dv, if I differentiate the function again, we got 6 now dv dt. Now what is v? V is actually ds dt. V is actually ds dt over dt. Okay, now this thing can be written as this d here, bring down here, that means there is 2 dt square. Then here d, so d2s. Okay, right? So this is basically acceleration dv dt. You take the velocity function, you differentiate again, you got dv dt. Okay, dv dt, this is velocity. The chain of velocity we expect divided by the time taken is actually a definition of acceleration. Okay, so displacement differentiate with respect to time, you get velocity. Velocity differentiate again with t, you got an acceleration. And then similarly, if you are given the acceleration in terms of let's say a certain t function, if you integrate, you go one step backward. The acceleration you integrate, you become velocity. Then you integrate velocity again, you become a displacement function. Okay, Now let's look at the velocity. Say this distance s, this t. Okay, let's say I have a s with a certain function. Okay, now if I take the gradient here, which is ds dt, what do I get? If I take this gradient with ds, the chain of the distance, and the time taken, the chain distance, this will actually give you the velocity. Okay, the gradient will actually give you the velocity. Now, another example. Let's say you got a different s function with respect to t. Now, let's say it's like that. Okay, how do you interpret this? By the time you reach here, let's say here, horizontal line, this is ds dt equal to 0. Okay, this become the turning point when ds dt equal to 0. Okay, at this point when it turn, its velocity is actually equal to 0. Okay, now what about the gradient? The gradient at this point is the velocity. The gradient here, if you take the, the, the gradient of the tangent is point is actually ds dt, and that gives you the velocity at this point. Let's say if I take the gradient of tangent at this point, then it becomes the velocity at this point. Now, you look carefully, if we slant this side, the gradient, okay, or the velocity is always positive, become positive. You look at the gradient at this point here, okay, the gradient is negative. Okay, the gradient is negative. By the time we reach the turning point, the gradient is becomes 0. Okay, now another thing you can look at this is this s, this t. Now, if you look at this point here, at this point, the particles, let's talk about particles. From here is reaching s equal to 0. Okay, s is defined as the distance from the initial point is s. Okay, so at this point here, the s is equal to 0. Means it is the particles is at this point, s is equal to 0. Then from here, the s become negative. It means to say the object for example, this case travel this way is going into the negative s. Okay. Then by the time we reach here, maximum distance, then the s become negative, s become less. That means it's coming back again. Okay, coming back. By the time we reach here, that means it just passed the 0 point, s go to 0, and then go back this direction. When it reach this point here, I mean from here it travel, and then the next instant the particle is at a positive s. That means it come out from here. Okay, now there is 4s. Now we're going to look at this velocity versus time, and see what does it mean.